Okay, hello everyone. Welcome back to statistics. So, uh, for one thing, it's interesting that we are already getting cold. I believe it's something like 50 degrees here now. Last week, we were talking about methods of collecting data. And so we were talking about things like the different types of studies we can have, the different types of variables we need to take into account. Um, and we were kind of organizing that. Today we're going to see what we do with data after we collect it, which is organize the data. So first of all, we need to understand that there are some characteristics of data that we need to take into consideration when we start organizing our data. And this is going to be pretty important for when we start thinking about things like graphs. What kind of graph do we want to use to express this data? So the first two types of characteristics are ordinal and nominal. These are opposites of each other. Data can either be ordinal or nominal. So ordinal data is going to be something like your grade. So A, B, C, D, and F. So those grades have an order to them. Of course, ordinal means ordered. So the order there in our grades is A is highest, and it's higher than B is higher than C is higher than D is higher than F. So there's order to those grades. So ordinal data is data that has order in it. So it intrinsically has some kind of hierarchy in that data. Nominal, on the other hand, doesn't have any kind of order to it. So an example of nominal data would be something like color. So if we, in class, were to take a survey of the color of everybody's shirt, we might have red, green, blue, black, gray, yellow, all sorts of colors, but there's no order to colors. They're just colors. So again, ordinal data is data that has order. Nominal does not have order. At least that's the simple way to look at it. The next two characteristics that data can have are qualitative or quantitative. So this isn't opposed to ordinal and nominal. In addition to ordinal and nominal, our data can also be either qualitative or quantitative. So qualitative data is, again, something like color. Color is a quality of that shirt. It's describing the shirt. So it's like a description. Okay? Quantitative, on the other hand, is opposite of qualitative. It is data that has quantity expressed through it. So, if we counted the buttons on those shirts instead, the number of buttons would be quantitative. It's a quantity. Okay, so one more time. Ordinal data is data that has order. Nominal data doesn't have any kind of order to it. Qualitative data has some kind of quality to it. It describes something. And quantitative assigns value. It assigns a quantity. So we can have a mix of these two groups of data characteristics. So, for instance, our grades. Our grades, A, B, C, D, and F, would be ordinal because they have order, and qualitative because they're describing a quality of that grade. Okay? So, again, we need to keep these characteristics in mind when we start organizing data. And again, we'll probably get to the graphs of data on Monday. So one other way that we can organize our data, probably the simplest way is with a frequency chart. And here I've got a sample frequency chart written up. Okay, I'm sorry, chart. Frequency distribution. Let's use the correct words. So a frequency distribution sounds kind of complicated, but it's really not. It's pretty simple. So let me go over to Hawks real quick and get an example here. So this example says, in order to help decide when and where to advertise, an appliance repair company decided to pull invoices and tally what types of appliances were repaired. There were 25 appliances repaired that month. Construct a frequency distribution for the data. Okay, so again, a frequency distribution is this chart that I've got outlined here. So how are we going to fill that in? Well, of course, we need the data, which is right down here. And this is a list of all the things that were repaired in a given month. So we've got a dryer, a washing machine, a refrigerator, microwave, dryer, another microwave, another dishwasher, so on and so forth. Okay? So the two basic things that you need for your frequency distribution is a score and a frequency. So the score is going to be the type of data it was. So like the name of the data. So for instance, here we have dryer, 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 dryer. All of these are the same type of data. Okay? So the score for that data is dryer. Okay. And then we need to go through and list all of these different types of appliances. So I'll go ahead and do that. We have washing machines, refrigerators, microwaves, and let's see, washing machine, refrigerator, microwave, dryer, and dishwasher. There's the other one. Dishwasher, microwave, refrigerator, and it has switched my language for some reason. That's why it's hitting on those. And it's still... what? I don't know. Okay, and what was the last one? Oh, I've forgotten already. Dryer, washing machine, washing machine. Okay. So those are all of our scores. Those are the types of data points that we have. The frequency is how many times we have those data points occur. So we just go over here and count up the number of times each one of them happens. So let's see, dryers. We have 1, 2, 3, 4, 5, 6. Happens 6 times. So we'll enter a frequency of 6 for that one. Dishwashers. Let's see. 1, 2, 3, 4, 5, 6, 7. Okay, microwaves. 1, 2, 3, 4, 5. Looks like 5. Refrigerators. 1. 2, 3, just 3. And finally, washing machines. Whoops. So let's see, 1, 2, 3, 4, maybe just 4. Okay. So now that we have all of our frequencies, a good idea is to take those frequencies and add them. Because if you add all of them up, it should be equal to the amount of data points you have. And we know that it says there were 25 appliances that were repaired at the company. So we should have 25 data points, so these should add up to 25. So let's go ahead and just add them, make sure that everything's good. So 6 plus 7 plus 5 plus 3 plus 4, and we do indeed get a sum of 25. So we've got all of our data points in. Next is relative frequency. So relative frequency is not a measure of how often it happens, like frequency it is, but it's a measure of how often it happens in relation to the rest of these. So, for instance, dryers happen 6 times. In relation to that, there are 25 other points, so it's 6 out of 25 times. So what we can say there is that the relative frequency for dryers would be 6 out of 25 again, so that's 6 divided by 25. When you hear someone say something out of something, so like in this case 6 out of 25, that's a ratio, and ratios represent fractions, which are just division. Okay, so 6 out of 25, we're going to have to go ahead and calculate that. 6 divided by 25 is 0.24. So the relative frequency for our dryer is 0.24. And we will go ahead and do that for the rest of these. Okay, so next one would be 7 out of 25. So 7 divided by 25 is going to give us 0.28. Next one, microwave, we have 5. So 5 divided by 25 is going to give us 0.2. Next one, refrigerators. That one's 3. So 3 divided by 25, we get 0.12. Next, we have washing machines, which is 4. So 4 divided by 25 is going to give us 0.16. Okay. Similar to how we added up all the frequencies and got 25 to make sure we got everything right, relative frequency, we can do kind of the same thing. So think about these as slices of pie. Okay? So like this slice right here is 6 pieces of 25ths. So it's 6 pieces of pie that were sliced in 25ths. Now, if we take up all of these pieces of pie all together and put them back together, we should get one whole pie. So, in the same idea, if we take all of these and add them together, then we should get 1. So, let's just check and make sure that we actually get 1. So, 0.24 plus 0.28 plus 0.2 plus 0.12 plus 0.16 equals exactly 1. So our relative frequencies look correct. Now, your relative frequencies should always add up to 1 or somewhere really, really close to 1. The reason that they might not be exactly 1, but just really, really close to it, is if we have to round these numbers. There might be a little bit of error when we round them. Now, if it's somewhere really far off from 1, maybe all the way up to like 1.5. You might want to go back and look at your calculations and make sure that you calculated everything correctly and everything's in the right place, because you don't want this to be all that far from 1. Maybe 1.01, that's fine. 0.9999, that's fine too. Those are both really close to 1. Much further than that, go back and take a look. Okay. So how about those percents? Well, we actually almost already have them. So our relative frequency, again, is a measure of how often this thing happens compared to everything else. So all we need to do is take these numbers and convert them to a percent, which we just need to multiply by 100, or move the decimal twice this way. So again, if we wanted to do the one for the dryer, that would be 0.24 times 100, which equals 24%. So this one, again, 24%. Next one, we've got 0.28. Move that decimal twice to the right, we have 28. So it's 28%. Same thing for all of these. 20%, 12%, 16%. And there's all of our percents. So the frequency by itself didn't really tell us a whole lot. Okay, we had 6 dryers. Cool, whatever. What can we do with that information? Well, we can convert this information into something more useful, like percents or relative frequencies. Both of these, well, relative frequency is a very useful thing in calculations. Percents are very useful to us just to kind of understand overall what's going on. So I can look at this and I can say, oh, well, 28% of the time we're dealing with dishwashers. We might want to advertise, since that's what we're doing, is figuring out how we need to advertise, but advertise that we can fix dishwashers. We need to put that up front. Refrigerators, maybe put it in a list on our flyer that we advertise with, but it doesn't need to be the upfront thing because it's only 12% of the time. Okay? So again, this is just a pretty simple frequency distribution. We just need the scores and the frequency for frequency distribution, but it's always a good idea to have the relative frequency and the percent as well. So one more time, the scores are just the data points that you have, the names of them. Frequency is how many times those particular data points pop up. Relative frequency is relative to how the others are. How many times does this thing happen? And then the percent is, of course, the percent of the time it comes up. So let's do one more frequency distribution. And I've got my own set of data for that. I'm just going to give us raw numbers. So 1, 1, 2, 2, 2, 2, 3, 4, 4, 5, 6, 6, 7. So just some raw numbers, raw set of data. Oops, and I forgot a comma there. And we can make a frequency distribution for this set of data as well. So, first of all, again, score. We need to have the names for our different data points. Well, in this case, we have the numbers. So, like, I know 1 is right there. Then we have some 2s. Then we have a 3, some 4s, 5, 6. So that's going to be our scores. How many times does 1 happen? What happens twice? How many times does 2 happen? 4 times. 3 only happens once. 4 twice. 5 once. 6 happens twice. 7 only once. So we have all of our types of data points, 1, 2, 3, 4, 5, 6, 7, and then the frequency, how many times they happen. So again, we should always try and make sure we have all of our frequencies. So we're going to add all these up together and see if we got all of them. So 2 plus 4 plus 1 plus 2 plus 1 plus 2 plus 1 That's going to give us a total of 13. So do we have 13 data points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. So it looks like we're good. Okay, relative frequency. So, again, it's a comparison of this frequency to the rest. So, this frequency, compared to the rest, that'd be 2 out of 13. Again, 2 out of 13 means 2 divided by 13. So 2 divided by 13 is going to give us 0.1538, so on and so forth. We have to round that. Typically we want 2 decimal places, so I'm going to use 2 here. So this will just round to 0.15. Next one, it's 4 out of 13. So 4 divided by 13. Again, we need to round. This one happens to round to 0.31. And I'll just round the rest of them for us. So 1 out of 13 is 0.08. 2 we already know. That's 0.15. 1 is another 0.08. Another 0.15. Another 0.08. There we go. So there's all of our relative frequencies. And now we need to see if these add up to something close to 1. Make sure that we've actually rounded all these numbers correctly and there's nothing weird going on. So let's see. 0.15 plus 0.31 plus 0.08 plus 0.15 plus 0.08 plus 0.15 plus 0.08 is exactly 1. So we got lucky there. Even though we rounded, our numbers still come out to exactly 1, which is ideal. And now the easiest part, percent. Just move that decimal over twice to the right, and we've got our percents. So 15%, 31%, 8%, 15%, 8%, 15%, and 8%. And there's our frequency distribution. So again, this is a nice, simple way to organize data, and it helps us get more useful data. Okay, so again, like I said, frequency just on its own, it's okay. It's not really going to tell us a whole lot, but we can use it to start learning more things about our data. All right. So, short lecture today. Friday, we will have a quiz. So, for those of you that are in the distance learning class, the Zoom class, you're going to be getting an email with your quiz in it. And along with that email, you're going to need to digitally sign a form that says you're not going to cheat. Okay, so your efforts are your own. But the way it's going to work is I send you that email with the quiz in it, and it's going to be in a Word file, kind of like this. So just, you can write down your answers, take a photo with your phone, and email that photo to me with your answers, or you could type your answers into the Word document, save it, and send it back to me. Just whatever you need to do to get me your answers. But preferably, I'd like to see work, so writing them down would help me. Okay? But I think that will do it for today. Remember, if you have any questions, you can ask me down in the YouTube comments below, or you can always email me at my Sulross email address. All right, I hope everyone has a great day, and I will see y'all on Friday.